1/2 times 60 kilograms times 8 meters per second times 8 meters per second, right? That's the velocity squared, right? And so 8 times 8 is 64. 1/2 times 60, 30. So then we have 30 times 64. That is 1,920 joules. Okay? Our potential energy at part 1, okay, which is right here, our potential energy is our mass times our height times gravity. So our mass is 60 kilograms, our height is 0 meters, our gravity is 10 meters per second squared, but that's still 0. Okay? Our mechanical energy is kinetic energy plus potential energy, which is 1,920 joules plus 0 joules. So it's just 1,920 joules. Okay? Yeah.
How does that have no potential energy?
Because its height right here is 0. So at the very beginning, that guy is on the ground. So his potential energy, his gravitational potential energy is 0. Okay? Does that make sense? Okay. So point 2, he's a little ways up, right? And his height now is 1 meter, right? Okay? So we're going to do it all again. This time we're going to start with, what do you guys want to start with? Potential or kinetic?
Potential.
Potential. So there's potential energy here at point 2. Potential energy is mass times height times gravity, which is, what's his mass? 60. What's his height? And gravity is about 10. So 60 times 1, 60 times 10, 600 joules.
What about big percent squared?
Right here.
6,000.
No, because we're not squaring gravity.
Oh.
We square velocity, right?
Oh, look that up.
Okay. So then the kinetic energy is 1/2 mass times the velocity squared. Okay. That's why when I write them like this, I put the squared outside the parentheses, so that we know what's inside the parentheses. Everything in there gets squared. Whereas when we do gravity, the s is all the seconds is already squared. Okay, so that helps you to remember that all of velocity means squared. Okay. All right, and we don't know his velocity, right? So we don't know what that is, but we do know his mass is 60 kilograms. Half of that, we're just going to say 1/2 60 kilograms times velocity squared is the same as 30 kilograms times velocity squared, right? Everybody with me still? Yeah. It was at the very beginning, right here, right? But as you go up that ramp on a skateboard, you go up, you're going to get slower, right? Because you're going up the ramp, because gravity is pulling back down on you. So as he goes up the ramp, he starts to slow down. Okay, so now his velocity has changed. We need to find the new velocity, okay? And so we know that the mechanical energy is still 1,920 joules, okay? That's the same as potential energy plus kinetic energy.
So we can just minus the potential energy here.
Okay, so we know potential energy, so we're going to say 1,920 joules is the same as potential energy, which is 600 joules, plus the kinetic energy.
It's actually 1,300 joules.
Where?
It's 1,320 joules.
Oh, I haven't minused it yet. Okay. Yes.
But how is the mechanical energy still the same?
Mechanical energy is always going to be the same. It's a constant. Okay, so that's the equation that we need in order to solve this. Okay, because we don't have any friction, energy that we have here at the bottom has to be the same energy here, has to be the same energy here, and then eventually when that skateboard runs out of velocity, it's going to start to roll back, right? But that mechanical energy will be the same the whole way. It's like a pendulum. You guys know what a pendulum is, where it keeps swinging back and forth like this? All that kinetic energy turns into potential energy up here at the top, and it stops, and then it comes back, and it turns into kinetic energy. All right here at the bottom is all kinetic energy, and then it comes up, and it turns into potential, back and forth, and it only stops because of friction. But if we forget about friction for a second, because it's too complicated for this, it'll just keep going forever, right? Same with this skateboarder guy. If there was another side to this ramp, he would just keep going up until he slowed down enough, and then he would go back until he slowed down enough, and go back and forth, and he'd be stuck forever. It'd be bad. So we're glad we have friction. Okay?
It would be very sad.
It'd be hard if we had no friction. Okay? So now we have our kinetic energy is equal to 1,320 joules, right?
You know those like metal balls that like this thing where it goes click?
Yep, that's the same thing. That's a pendulum. All of that energy comes and it hits one of those other balls, and that ball doesn't move, but the energy passes through it. Okay, passes through this ball onto the next ball, onto the next ball, onto the next ball, until that very last ball takes all the energy, and then it moves until its potential energy becomes more than its kinetic energy, and then it comes back, and that energy gets passed through each ball until it hits this one, and then it goes like that. Yeah.
Right, keep going forever and ever.
If there was no friction. If there was no friction. But because there's friction, it won't. We don't have time for that. We gotta finish this real quick so I can show you guys how it works. Okay, real quick. Kinetic energy is now 1,320 joules. We're gonna plug that into here, okay? So now we have 30 kilograms times velocity squared, 1320 joules. 1320 divided by 30.
How did you find out it was 1320?
So we had our total is 1920s, right? That's our mechanical energy that we found earlier. We know that our potential energy is 600. And so we said 1920 joules plus our 600 for potential energy plus our kinetic energy. We're going to minus the 600 across, and that gave us the 3,020. Okay? Because the 1920 minus the 600 is 1320. You plug that in here. Yep, velocity squared is equal to 44. And so then velocity is equal to the square root of 44, which is not a nice number. So that's it. The square root of 44 meters per second.
What is that? That was just 44.
No. So if we did 22 times 22, we would have 4 times 4. And then we have 4 times 4, right? So it would be 484. It would be 22 squared, right? Okay, yes. Okay, so were you with me until this point? You understand this part? So our kinetic energy is equal to 1,360 joules. Right? And we minus the 600 across. And then we come here and we say kinetic energy is the same as 30 joules, 30 kilograms times velocity squared. But we know kinetic energy is also equal to 1,000. So we said D is equal to each other. So 30 kilograms times velocity squared is equal to 1,000. Divide both sides by 30.
Stapled to one of those like massive pixie.
Divide both sides by the 30 kilograms.
I think I plugged it.
And take the square root.
That's super cute, but I can't seal it. If I was in a different school, I would just steal everything from it.
All right.
I'm in the same school too, so I'm like, I can't.
So we had this is our kinetic energy, right? That we decided 1,320.
This is why I don't get
We
anything
plugged it back in here to this equation. And this equation told us that 30 kilograms times velocity squared is kinetic energy. Okay, so we took 30 kilograms times velocity squared, because that's our 1/2 times our mass times velocity squared. And we plugged this in for kinetic energy. So then we got 30 kilograms times velocity squared. It's the same as 1,000 1,320 joules. We divided by 30, and that gave us velocity squared is 44. Okay? So 1,320 divided by 30 is 44. So we're left with just velocity squared is 44. And so velocity is the square root of 44. So you can do it with a calculator, but it's too, if you don't have a calculator, this is good enough. Okay? If you do have a calculator, you'll find out that it's like 6.6